All right, we live. All right, so first question I got, right, is negative square root 96. Appreciate it, man. All right, so what you want to do, right? You want to look for the largest perfect square that goes into this, right? So let's go through our perfect squares. So I have 1, 4, 9, 16, 25, 36, 49. What comes after 49? 64, right? And then we got 81, and then we got 100. Now I'm gonna stop at 100 because 100 is bigger than 96. So I already know that's not even the answer, right? But 81, can 81 go into 96 evenly? Not evenly, right? It goes in once, but there's gonna be some remainder. 64, if I double 64, I get 128. That's not gonna work either. 49. If I double 49, I get what? Not 100. I got like 98, right? Something like that. Yeah, so 49 is not gonna work. How about 36, right? So if I double 36, 72. If I triple it, right, that's gonna be what? 108? Nah, that ain't it. 25, I know it's not that. 16, right? Nine. Yeah. Is 16? So 16 times what? All right. It's times six, yeah. So this breaks down to square root 16 times square root 6, right? Don't forget that negative, right? And then we know that the square root of 16 is what? 4, right? So this is negative 4 square root 6. So on your test, excuse me, on your test, on your homework, right? They're gonna give you some kind of question where you're gonna have something like a square root c, something like that, right? A is the coefficient that's in front, c is the radicand, right? In our question here, right, our a is equal to negative 4, and then our c was underneath the radical, that's the 6, and that's it. That's how you would do that. No, no, take your time, no problem. So that's why I love the library. Like, there's a whole bunch of outlets that actually work, all over the place. Yeah, so another one. Right? Yeah. So which one is it? Tell me. Okay. Boy. Say it again one time. Oh, the negative, like negative square root 540, like that? Okay. Oh, like this? Oh, on the root itself? Like that? Okay. So that's cube root of 540, right? Huh? Oh, this? So this is one times one. This one is two times two. And then this is three times three. All right, and then all the way down here. Mm-hmm. The same number, like just counting. One, two, three, four, five, six. Yeah. All right. So here's another question. We want to do the cube root of negative 540, right? All right, I'm not gonna lie to you, I don't know. Right? So here's what I go to when I don't know, right? I take the 540, break it down into two numbers and multiply the 540. So 54 and 10 for me, right? And then I can break down the 10 into what? 5 and 2. These are prime numbers. That's what I'm trying to break it down for, right? I'm going to divide this one out by 2. So this is 2 again. So this is going to be 25, what? 26, 27. All right, I'm good with the 27 because I know that that's just what? 9 and 3. And then this is what? 3 and 3. So these are my prime numbers, right? Let's count them. I have one, two, I have three threes, right? And I have two twos and two fives. So look, this is gonna be look the cube root. Like this is what this becomes: a cube root of 3 to the third power times 2 to the second power times 5. Technically to the one power, but you get the idea, right? All right. I want to separate the perfect cube, right? So there's only one perfect cube here. So this is going to become what? The cube root of 3 to the third power times the cube root of whatever 2 squared times 5 is. Now you already know the cube root of 3, these are going to cancel out, right? Leaving back just the big 3 in the front. And then we're going to have the cube root of 2 times 2, I think that's like 4, right? And then 4 times 5, what's that, like 20? So this is your answer. And if it's another one of those ABC questions or whatever, so if it's like, hold on, if it's like this, um cube root of C, then your A in this case would be 3, and your C would just be 20, like that. Yeah. The which one? Yeah, the 3 on the outside is A. If you're doing it like this, I don't know the question, but if it looks like that, then that's what it is. A is 3 and C is 20. Yeah. So yeah, when I see a crazy number, I don't know how to do it. Just break it down to your prime factors and you can count, right? But remember, your count has to be divisible by the index, right? The index being what's on the radical right here, right? It has to be divisible by that. Then it cancels out, pop, pop, and you're good to go. Yeah. Oh, hold on a second. This is negative, isn't it? It's -3. Sorry about that. Yeah. So my mistake. This is -3 in parentheses right here. My fault. My fault. My fault. Yeah, so we're gonna pull out the negative with the perfect cubes. Yeah. Oh, you know what? Hold on. I didn't put the negative on the 3 over here. All right, we good to go. Good to go. All right. Any other questions from the homework? Anything? Any topic that y'all not understanding? Oh, like this, square root of 48? Yeah. Or like this? So the fourth root of 48. Yeah, yeah. So I'm not even gonna lie to you. I don't know what the answer to this either. Right? So I'm gonna just start off with 48, right? Break it down into two numbers I do know. So I know that 4 goes into this, right? This is like what? 4 times 12. Am I right about that? Yeah. Yeah. And just break down the 4, right? That's 2 and 2. Those are prime numbers. Then we're gonna break down the 12. This is what, 2 and 6, right? Then we're gonna break down the 6. This is like what, 3 and 2. Now I want to count. Yeah, break it down to the basic prime factors. And then you just count them, right? So this is gonna become what? The fourth root of how many twos do I have? One, two, three, four. 2 to the fourth power times 3, right? Now let me separate them. This is going to become what? The fourth root of 2 to the 4 times the fourth root of 3. Now you already know the fourth root and the 4 is going to cancel out. So my final answer is going to be what? 2 fourth root of 3. And again, if this is one of those ABC questions, so if it's like A fourth root of C, your A in this case would be 2, and your C in this case would be 3. That's it. C being your radicand, right? And A being your coefficient. What? When you I just count them. No, I count them. So yeah, 1, 2, 3, 4. Yeah, yeah. Yeah, that's what's nice about prime factorization. You can just count it. You don't have to memorize nothing, just count it. Yeah. And that's it. Yeah. Any more? That's it. One more? All right. Yeah, the trick is just use the prime factorization and then just count out the numbers and you're good to go. All the square numbers? But you could generate it on your calculator. Yeah. One times one, one. Two times two, four. Three times three, nine. Yeah. No, no. You could put it in a list though. It's not impossible. Um, you can make it. Like you could type in the function and then it can generate the list for you. So the function that you would want is called x squared, right? So f of x equals x squared. And then for every x, you just plug it in regular numbers, 1, 2, 3, 4, 5, 6, and it'll just square each number for you. Whenever you square a number, you're multiplying it by itself. So like 3 squared is 3 times 3. 4 squared is like 4 times 4. So you could just enter in the numbers and then generate the list yourself. Not too bad. All right, let's jump into today's lesson. This is going to be another one of those like quickies but goodies. Mhm. Ooh, bear with me 1 second. My app is closed. Why is my app closed? This is my fault. It's not your fault. All right, before we jump into today's lesson though, I just want to do a little blast from the past. Make sure we all on the same page. How do I do this again? I forgot. What should I do here? This is my first step. Nobody? All right. So you should distribute the negative over here. In a sense, what I'm telling you to do is to just change all the signs of the polynomial that's next to it, right? So this becomes what? 3x squared plus 9x minus 5 minus x squared plus 2x minus 3. After that, just combine like terms, right? So remember, combined like terms is just a fancy way of saying add, right? So I have the x squares to add. So what is 3 plus -1? What's 3 plus -1? 2, right? So this is 2x squared. All right, now I'm done with these. So now I want my x's, right? I have 9x and I have 2x. So what's 9x plus 2x? Right? So plus 11x. Now I'm done with these. So now I have -5 and -3. So what's -5 plus -3? -8. All right, I'm done. This is my answer. Questions on this, anybody? It's just a little bit of distributing and then combining like terms and all that. What? Right. Well, because the negative is next to the parentheses, that's what makes you do that. Right. Yeah. Always to the right. Mhm. Right. Just add the like terms, and that's it. All right. Who remembers how to do this? Little different. How do I simplify this? Starts with a D. I have to a D distribute. All right. So let's distribute this. So I got 2 times 4. That's 8. 2 times negative a. That's minus 2a. A times 4. This is going to be plus 4a. And then a positive a times negative a will be negative a squared. After that, let's combine like terms. We're just adding these two. So negative 2a plus 4a, that's going to give me an 8 plus 2a minus a squared. That's it. Questions on this? Anybody? All right, one more, one more. All right, try that out. Need some. Gotta check my score. So y'all have fun with that. Wow, still 0-0. Penalty shots, 1-1. I don't know. I want Colombia to win. Colombia over Switzerland. Although I do like the clocks and I do like the chocolate. Yeah. Huh? Yeah, this last one. My fault. Exciting? Exactly. Mm-hmm. So you can either multiply it straight out, or you can use a shortcut. So let me remind y'all of the shortcut. We have a minus b squared, right? And this becomes what? A squared minus 2ab plus b squared, all right? You guys can just directly use that same shortcut. This would be what? 9 minus 5y squared equals what? 9 squared minus 2 times 9 times 5y plus 5y squared. Let me just do the math on it. 81 minus, oh shoot. What's 45 times 2 again? Like 90, something like that? Yeah, so 90y plus 25y squared. So you can do it that way, or uh, 90y because it's two times 9 times 5y. Yeah, so 90y, yeah. So now if this didn't make sense to you guys, you're more than welcome to just write it twice and then distribute it out. You will get the same answer. All right. You will get the same answer if you want to do it like that. All right. Your choice, no pressure. Mhm. I just happen to remember the shortcut. Mhm. Yep. Negative 45. Yeah. And then negative 45, which add together became to make negative 90. And then negative 5y times negative 5y is positive 25y squared. Yeah. Yeah. So whichever method works best for you, you guys can do. I'm not upset if you guys don't remember the trick. All right. It's more important for me that you guys know how to distribute than it is for you to just know a whole bag of tricks. All right. We have time to work on those later. All right. So here's what we're getting into today. We're going to be, we're going to add and subtract radical expressions. All right. Taking it up a notch. So adding radical expressions with the same index and the same radicand is just like adding like terms. We call radicals with the same index and the same radicand like radicals. All right. To remind us that they work the same as like terms. Okay. So let's review that real quick. Like radicals are radical expressions with the same index and the same radicand. That's important. All right. We add and subtract like radicals in the same way we add and subtract like terms. So we know that 3x plus 8x is equal to 11x, right? Similarly, 3 radical x plus 8 radical x equals 11 radical x, right? So we just added the coefficient, a number in front. Think about adding like terms with variables as you do the next few examples. When you have like radicals, you just add or subtract the coefficients. When the radicals are not alike, you cannot combine like terms. All right, remember that. So let's try this out. I'll leave the example up here. You guys try these, and then we'll go over it. You could use a calculator. All right. Not gonna lie, I'm over here counting my fingers. First one is like 2 minus 7. You know? Yeah, yeah, yeah. You want to try the first one? So look, it's 2 radical 2 minus 7 radical 2 is equal to what? All right, look, look, look. So look, look, look. What's this? What's the answer? 2x minus 7x equals what? Negative 5x. So 2 radical 2 minus 7 radical 2 equals what? Right. So if 2x minus 7x equals negative 5x, 2 radical 2 minus 7 radical 2 equals what? Yeah. What is it? Negative 5. What? Not x, negative 5. What's next to it? Radical 2. That's it. That's the answer. Hmm? You want to try the next one? I have 5 cube root of y plus 4 cube root of y. How you write y again? I forgot. Like that, right? All right, what's the answer? Just add the coefficient, the number in front. That's all. Yeah. So what's the answer? That's it. 9 what? Cube. Cube root of. That's it. That's the full answer. That's all it is. All right, let's look at C real quick. So I have 7 fourth root of x minus 2 fourth root of y. What's the answer? Mhm. What's the answer here, you guys? What y'all think? Mm-mm. Mm-mm. What's different about this? Huh? No, not that. There's something different about this. What is it? What's the answer? What do y'all think? Hmm? Yeah, you're gonna subtract it. Nah, that's not it. Hmm. Nobody? Really? All right, this is the final answer right here. But why is that though? What's different about this compared to the other two questions? Right. The radicand is different. You see how this is fourth root y, fourth root x? But you see how these are the same, right? The same, right? So you can only combine like terms. And when they're not like terms, you just leave it alone. Yeah. Yeah, this is third test. Third test. Yeah. Yeah. That's it. Just adding and subtracting. Yep. Y'all want to see another one or we can move on? Huh? All right. All right, try this out. All right. So just to be clear, like this is A, all right? Um, that's B, and you can see C. Try it out. It's a little subtraction and adding, right? If you feel like you don't know the numbers, you could count your fingers or use your calculator. No problem. What's the answer? Negative one, what? Negative one, what? Square root two. That's it. All right. How about B? 11 what? Cube root. Cube root. Cube root. Or you could say the third root. Yeah. Uh-huh. Of X, right? What about C? A little bit harder. Right. That's the answer. Why is that the answer? Right. You not like terms. Questions on this? Anybody? I got another example for y'all. Mhm. Huh? They're winning? Oh well. Because they're doing a shootout right now. The game is over. Yeah. All right, real quick. New example. So for radicals to be like, they must have the same index and radicand. So the index is the root, square root, cube root, fourth root, fifth root, etc. Has to have the same index and the same radicand. Radicand is what's underneath the radical. All right. When the radicands contain more than one variable, as long as all the variables and their exponents are identical, the radicands are the same. All right. So try this out. This is two questions. It's an A and a B. While I check my score. Yippee. All right, they got full time penalty. Switzerland wins. Colombia. Yeah, I'm tight. Yeah, Colombia lost. I'm tight. Yeah. America's um Morocco is in there, yeah. Egypt just lost to Argentina, yeah, today. Yeah. Nah, Egypt was up 2-1, 2-0, I heard, the whole game. And all of a sudden here come like three goals. That's it. Yeah. I mean, I knew they were going to the final already. Yeah. 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 They gonna probably get to the next match, Argentina and Norway. I don't know. England did their thing, but I feel like Norway might be the better team. Yeah. Yeah. Yeah, with Kane. Yeah, he does his thing. Yeah. Yo, Verde, yeah. Yeah, I feel like Cape Verde is the closest that like like our countries will ever come to the World Cup. Yo. Yeah. Yeah. Mm-hmm. It's not like the other ones. Mm-hmm. Yeah. I'm not sure. I'm not sure. Neymar. Neymar. Yeah, yeah. Yeah. Probably. Some of these people mad old. Like Ronaldo's mad old. Like, yo. Yeah. Yeah. They probably played with David Beckham. That's how old they are. Hmm? Yeah. 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 But when you got money, you could invest in your team, and that's how you get to the finals. Yeah. There was this lady I was watching on I think it was Instagram or whatever, right? And she was making a point. So she was saying how the only teams that go to like the finals or whatever are teams that are from like the northern hemisphere, you know, because they dedicate more money to their team, so that's why they win. When everybody else just gets knocked out. And all of these people are from the northern hemisphere, like every last one of them. Oh yeah, we in the eighth now. The quarterfinals. France, Morocco, Spain, Belgium, Norway, England, and Argentina, Switzerland. Yeah. 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 I feel like the final two is Argentina versus somebody. I don't know who. Nah, they gonna knock out either England or Norway. Yeah. I feel like it's Argentina versus either France, Morocco, Spain, or Belgium in the final two. Like, they gonna go all the way. They have the easiest walk. Yeah. But between France, Morocco, Spain, and Belgium, you think they're better than Argentina? Yeah. Yeah. Against Argentina. Yeah. France is good, yeah. Day after tomorrow they play. That's the problem. Like, if it was basketball, you have to win 7 games just before you advance. Like this thing is one game, yeah. Like this is yeah. You can have one bad day and you can't recover from it in soccer. Like that's it. Yeah. 90 minutes. 90 minutes just running up and down. Yeah. 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 Mhm. All right, let's take a look at this. So just so I'm clear, right? This is my question here, right? So I have 2 square root 5n minus 6 square roots 5n plus 4 square root 5n, right? So now we just do like coefficients. This is 2 minus 6 plus 4, right? Times the square root of 5n. And we can just do the numbers in front. 2 minus 6, -4. -4 plus 4 is 0. So 0. Questions on this? So they have the same variables, square root 5n, square root 5n, square root 5n. So we just adding straight across. So 2 plus -6 is -4, and a -4 plus 4 is 0. And you know anything times 0 is 0, right? So that's why I just put 0 at the end. But technically speaking, it's 0 square root 59. Technically speaking. Which one? Just add the coefficients to number front. That's it. Hmm? Yeah. Technically, the answer should be 0 square root 5n, but because anything times 0 is 0, you know. Yeah. -4 plus 4, which is well, anything times 0 is 0, so that's why I just left it out. But technically speaking, yeah, it is 0 5 square root 5n. Is the answer. All right, how about B? How about B? Yeah, we will. How about B? I have no. So we have the fourth root of 3x. Excuse me, fourth root of 3xy plus 5 fourth root of 3xy minus 4 fourth root of 3xy. What's the answer? Just do the coefficients. What's the answer? I'm sorry? Mm-hmm. 1 plus 5. Fourth root. Hmm? Not quite. You're close. Not multiply. You're doing you're adding and subtracting, so we're just gonna do the coefficient. So 1 plus 5 is 6, and then 6 minus 4 is so that's the answer. 2. It's all good. So 2 fourth root 3xy. Questions on this? All right. Hmm? Okay. Try that out. Yeah, I got that. Uh-huh. Man, I need students. I don't even have 20 people yet. I could do 30, like 10. Yeah. 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 The same time as this class in the fall. It's the same thing like now. Yeah. It's just Monday and Wednesday though. Just 2 days. Yeah. Hmm? Yeah. Yeah. Gotcha. Yeah. Yeah. Report, gotcha. Yeah. When I was a student here, that's what I used to do. I used to leave here mad late, you know? Like so Monday, Tuesday, Wednesday, like even if I finish class early, I'm in the library doing homework. Library used to close at 10 back in the day. Four, just four. Yeah, but I'm always studying for them, you know? And then how's it go? Thursday though, I would still leave late, but like me and my friends we go to the bar after, you know? So be chill. Thirsty Thursdays, you know? All right, let's take a look. So what's the answer for A? So 1 minus 7, that'll give you -6. So final answer, -2, square root 7x. That's it. What about B? Uh-huh. Exam 3. Hmm? Yeah, that's the easiest exam in the whole class. Hmm. That's one topic on there. Yeah, it's four questions. Yeah. Mhm. 1 plus 2 is 3. Right, so -4, fourth root 5xy. That's it. Questions on this? Anybody? It's just 1 plus 2, then -7. That's like 3 minus 7 is -4. No questions? All right. Let's go on to a new topic. So remember, right, that we always simplify the radicals by removing the largest factor from the radicand that is a power of the index. Once each radical is simplified, we can then decide if they are like radicals. So let's take a look. I'm gonna try out A. So I have square root 20 plus 3 square root 5. You know I could break down square root 20. That's just what? Square root 4 times square root 5. Well, and then what's the square root of 4? 2, right? So this is 2 square root 5 plus 3 square root 5. So add them. What is it? Hmm? No, what is it? You about to say it? Go ahead. 5, what? Square root 5. Perfect. That's it. Yeah, 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 yeah. Yeah. Yeah.
Let's see you saying. I just got my square.
Just simplify it, then you add it. All right, try B, try C.
So two numbers. No.
So you have to simplify them. It has to be a perfect cube.
Three numbers.
3 numbers, yeah. Like like 4 times 4 times 4. 3 numbers.
So he's.
So y'all better get 100 on exam 3. Ready? Yeah. I'm dropping the lowest exam grade, so you already know. Yeah, yeah. It's on the announcements. Yeah, you can check that out. Mhm. No imaginary numbers. No imaginary numbers. Okay. No. Appreciate you for the announcement. I'll be right back. But try those last two anytime. Let's go back and see. Yeah, England over there. I see why they left on that page. All right. Yeah, they all on that. They all on that map. Yeah. Mm-hmm. Mm-hmm. Yeah. Well, let's see. Let's see. I'm gonna try this out. So cube root 24 minus cube root 375. Now, I don't really know how to do this, so I'm gonna use my tree, right? So I have 24, break that down. That's 12 and 2, 2 and 6, 3 and 2. I have 1, 2, 3 twos, right? So this is gonna be cube root of 2 to the third times cube root of 3 minus, and let's do the 375, right? So, all right, we know 25 goes into that, right? So that's like what? How many quarters is 375? It's it's not 16, it's like 15 quarters, right? Yeah, to get $3.75. It's like, yeah, so like 15 quarters. So then this is what, this is 5 and 5. We're done with that. And this is what? This is 5 and 3. All right? Yeah, yeah, yeah. So cube root, no, but for the recording, that's fine. So this is gonna be cube root 5 to the third power times cube root of 3. Right? These will cancel. So I have 2 cube root of 3 minus 5. Hold on. Cube root of 3. They have the same radical, right? They have the same index, the same radicand. So 2 minus 5 is what? Close. Give me a better answer. Yeah. -3, right? So this is -3 cube root of 3. And then that's it. Questions on this? We'll choose a different color now for C. Now for C, I have 1/2 fourth root of 48 minus 2 over 3 fourth root of 243. All right, I'm gonna play the same game because I have no idea. So let's start off with 48. We know 48 is what? 12 and 4, right? And then 4 is 2 and 2. And then 12 is 2 and 6. And then 3 and 2. So this is 1/2 fourth root of 2 to the fourth times the fourth root of 3 minus 2 over 3, right? And let's do the 243. Let me see. 243, I know it's divisible by 3. That's 81. So 81 and 3. 9 and 9. 3, 3, 3, 3. Right? So that's just 3 to the fifth power. So I'm going to separate that. This is going to become the fourth root of 3 to the fourth times the fourth root of 3 to the 1 power. Why did I do that? Right? Because I want to knock out the radical with its index. So this becomes what? 1/2 times 2 over 1 times the fourth root of 3 minus 2 over 3, right? Times 3 over 1 times the fourth root of 3. All right. A little bit of math. 1/2 times 2/1. That's just one. So this is just the fourth root of 3. Minus 2/3. About this. This is 2. Fourth root of 3. And 1 minus 2 is what? Close. -1, right? -1 fourth root of 3. That's it. Questions on this, anybody? My fault, man. Sorry about that. You're welcome. This is the same procedure as before. Try it out. Mhm. Simplify, then combine like terms. Yeah. I'm sorry? Simplify, yeah. Simplify, then you could combine like terms.
Yeah,
Okay.
all right.
Yep.
So I got
So let's start off with the simplify. What did you get first?
3.
3 for the first one?
False.
So what's square root 50m squared? What does that become?
So,
So look, here's what I want you to do. Break this up into the largest perfect square that goes into. So this would be square root 25 times m squared times square root of 2, right? And then this becomes 9 times 5m plus 2. Wait, sorry about that. Square root 2, which becomes 45m. Hmm? No, but that's a piece of it. So now we got to do this part. All right. So minus, and then break up. Largest perfect square that goes into it. I believe it's what, no, like 16, no? 16 times 3, something like that.
Yeah, so 6 times 3 is gonna be 88.
Yeah, so 6 square root 16m squared times square root 3. Like that. Why 3? Because 3 times 16, right? 40. Because 24 and 2 is not perfect. I need a perfect square for this. 3 times 16 is 48. Yeah. Because it has to be like when I say perfect squares, I mean like 1, 4, 9, 16. You know that list from before? Like that. It's one of those numbers. But 24 doesn't have one of those numbers. This becomes what? Minus 6 times square root of 16 is 4. So 4m. Cube root of 3. Multiply these out. So we have 24 m's. Sorry, 24 m square root 3. No. What's the answer? No. What's the answer here? It's a real simple answer. No. What's the answer? Mm-hmm. No. Oh, that was the answer. Yeah.
So
So what's the final answer? No, not 26. Anybody? What's the answer? Huh? Yeah. So combine the like terms. Uh, mhm. Not both of them. No guesses? Yeah.
so we did to front end,
Mhm.
negative one.
Awesome. All right, this is the final answer right here.
Supposed to say 7
But why though? Why is that the final answer?
because the number inside the square is different.
Exactly. Right? They're not like terms. Yeah.
The negative 6, right?
Uh-huh.
What about if we made a mistake with the test and then we get 1 the square one?
It's just like a point off. It's not bad. So instead of 100, you get like 99.
Because you're gonna ask, or you're gonna destroy the things.
Get like a point off. It's not bad. How about this? This is cube root 54 n to the fifth power minus the cube root of 16 n to the fifth power. Try it out. Remember, simplify it first and then subtract. Mm-hmm. All right. What you got?
It's gonna be your
Mm-hmm.
part time. Nine. Because I'm used to not, divide by six. So it's
Not
like
not nine. Let's try it out. 54, right?
divide by six.
All right, let me do it by two because I'm not that good at math. It's 25, 26, 27. And then this is 9 and 3. And then 3 and 3. Okay. But it has to be perfect cube. So this is going to be 3 to the third times n to the third, right? Times the cube root of 2 n to the second power. See that? So perfect cubes in the first one, the remainder in the second one, right? Do the same thing with the next one.
Well, okay. So what would makes a perfect? Because this one's perfect, here is four.
Say it again. For 16, it would be 2 2 to the 4 power. So it's going to be the cube root of 2 to the third times n to the third times the cube root of 2 n to the second. All right, let's see. So then now let's see what we have. These will cancel. So I have 3n cube root of 2n squared minus 2n times cube root. I'm sorry. Yeah, times. Yeah, 2 to the n squared, like that. And then now, because they have the same radicand and the same index, 3n minus 2n is 1n, right? So this is just 1n cubed of 2n squared. That's it. You don't really need the 1 there. Just leave it as n. That's it. What questions on this? Okay. See you. Bye. Just want to jog our memory a little bit. So we have the product property of roots for any real number, the nth root of a and the nth root of b, and for any integer n greater than or equal to 2, the nth root of a times b is equal to the nth root of a times the nth root of b. And the nth root of a times the nth root of b is equal to the nth root of a times b. Okay? All right, new concept. It's gonna be real simple, right? So when we multiply two radicals, they must have the same index. Once we multiply the radicals, we then look for factors that are a power of the index and simplify the radical whenever possible. Multiplying radicals with coefficients is much like multiplying variables with coefficients. So multiply 4x times 3y, we multiply the coefficients together and then round the variables. So the result is 12xy, right? So keep this in mind as you do these examples. So for A, have 6 radical 2 times 3 radical 10. Try it. And then for B, I have negative 5 cube root of 4 plus 4 plus 2. Negative 5 cube root of 4 times negative 4 cube root of 6. All right, try it out. The hint here when you're multiplying, right? Numbers with numbers, radicands or radicands. Mhm. Well, let's try it out. 18 what? You're right. 18 square root 20. That's the answer. Yeah.
I know,
Right? Numbers with numbers. Yeah. Numbers with numbers, radicals with radicals. And that's it. Yeah. How about B? What's the answer? No. Negative times negative is a so 20 what? Cube root of hold on. Before. But you should see if you could break these down further. This could be square root 4, square root 5. Square root of 4 is 2. 36, square root 2. 24, that could get broken down into, I think, 8 times 3. And then knocking that out, I have 20 times 2. And so this final answer is 40 cube root of 3. All right. Questions on this?
so you read the school before the school, not question. You put it in, so.
Right.
The sheet becomes a little loud. They don't want to really.
Yeah, that's it.
Or, oh, I forgot to ask them.
And they weren't like terms?
Well, I have written down.
Nah, there's nothing else to do. You good?
Let's say I got 18, squares one, I'm not writing down.
Uh-huh.
Supposed to give us some blank.
Nah, you good. Let's look at this example. All right, try it out. Remember to simplify. Good.
Where,
Break it up first, though. So this would be 6 square roots x squared square root 6. Is 8. Hold on. So break it down. That's 15 times 4, right? This is 15 x to the 4th. All right, these will cancel. This leaves back 6 times x square root 6. All right, and this is 8 times 4, 1632. You're right. 32, 4 through to 15. Well, now you want to multiply these together, right? Numbers with numbers, radicals are radicals. So what does this become? This is, I think 72. No. 6 times 32 is what? Mm-hmm. Okay. So 188, 4th root of what? Actually, wait, no. This would be, why do I have a 4th root here? It's not supposed to be 4th root. Hold on. I am getting tired. 1 second. Might gotta call this a little early. Let me try this again. Hold on. That's a square root. This is 8 times square root 4, square root 4 x to the fourth, square root 15. 15 times 4 is 30. 60. Wait, hold on. This is square root 2, isn't it? Mm-mm.
You know the triangle, right?
I am tapping out right now. Wait, 15 times 2 is that? Five, three. Actually, nah, 30 is not even gonna work. Because 30 is what? It's 5 times 6, 3 times 2. Nah, it doesn't work. So this becomes square root x to the fourth, square root 30. All right. So this is just going to be 6x square root 6 times 8 x to the second square root 30. Multiply these together. 6 and 6 is 12, 24, 48. This is 48x to the third times the square root of 180, as you were saying, right? Go ahead.
Back to going back and forth, like,
No, that's just me.
because didn't I see this, oh, yeah, because they are.
Yeah. Mm-hmm.
Well, what about time was, display the 48, right, square.
Uh-huh.
Just give it the total, 48 square.
If you get the answer, I'm happy. Mhm. So I have doubles, double three, double two. So this becomes 48 x to the third square root 3 to the second times 2 to the second times square root 5. This will become 48 x to the third times 3 times 2 times square root 5. And then 48 times 3 times 2 is what?
48 and 3.
Times 2. So 48 times 5, what's that? Yeah.
So. Hundred, 8, 40.
240. Yeah. So 240 x cubed square root 5. Ah, that was a lot. Hmm? Uh, nah, we still got B. The idea here, numbers with numbers, right? Radicals are radicals. If you can simplify the radical first, then multiply it. All right, just bear with me for like two more examples after this one, and then we could call it. All right, let me just do this real quick, right? All right. So I want to break this down. Let's see, 12 to 6, 2, 3, 2. Can't do nothing with that. And 8. Can't do nothing with that. All right. So this is going to be -4. I really can't do nothing with this. Fourth root of 12y cubed times negative fourth root of 8, which is 2 to the third. No, can't do nothing. 8y cubed. Okay. Multiplying these together, negatives, negatives, positives. It's going to give me 4. And then fourth root of, let's see, 12 times 8. What's 12 times 8 again? I forgot. 12 times 8. Was that like 96 or something? Yeah. So 96. And then y to the third times y to the third is y to the third times y to the third. No, it's y to the. When we multiply exponents, what do we do with the powers? Starts with an A. No, we add the powers, right? So 3 plus 3, this is 6. Now let's see if I can simplify this. This is going to be 4, fourth root of, let's see, 96. This is 12 and 8. This is 4 and 2, 2 and 2, 2 and 6, 3 and 2. I have 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5 twos and a 3. So this is just 2 to the 4, all right? Y to the 4 times the fourth root of 2 times 3 times y to the second, right? These will cancel. This becomes what? 4 times 2 times y, fourth root of 2 times 3 times y second. So this is 8y, fourth root, 2 times 3, 6y squared. This is my final answer. Yeah. To be honest with you, I don't even think you guys got that on your homework, but just so that you guys could see it, right? Yeah. Mhm.
You don't complicate it with y, you know,
Right.
so you have each y and then y inside. I mean, what are you gonna use? Because you're gonna try to combine the y and then you're gonna use y.
Yeah. Whenever you see me splitting the variable like that, like y6, right? I'm doing it by the index, right? So this is the fourth root. So y to the fourth power, is divisible. And then whatever's left over, I leave on the other side as y squared, right? So that's how I'm doing that one. All right, just bear with me 2 more examples and we'll call it at that. Hey, how you feeling? That's good. All right, tomorrow. All right, just give me 2 examples and then we'll call it real quick, real quick, real quick. I'm gonna just make this real quick. Last part of your homework. So we're gonna use polynomial multiplication to multiply radical expressions. So in the next few examples, we will use a distributive property to multiply expressions with radicals. First, we will distribute and then simplify the radical when possible. All right, check this out. All right, let's say for 8. What the hell? Hold on a second. All right, bear with me 1 second. All right, let's say for A, right? I have square root 6 times square root 2 plus square root 18, right? Now, I could kind of simplify square root 18 a little bit, right? This would become square root 6 times square root 2 plus square root 9 times square root 2, which will become square root 6 times square root 2 plus 3 square root 2. 1 plus 3, that's what? Like 4, right? So this is square root 6 times 4 square root 2. Now, same thing, right? Just distribute it out. Numbers with numbers, radicands with radicands, right? So this is just what? 4 times 1 is 4. And then square root 6 times 2 is 12. Well, we could simplify that down, right? So this will become what? 4 square root 4 times square root 3. Square root of 4 is 2. So this is 4 times 2 square root 3. Call that 8 square root 3. And that's my answer. Nah, simplify it. Yeah. I mean, but yo, to be honest with you, your calculator could do it for you. Yeah. Yeah.
What about things, six and
What do you mean?
instead of one, two?
No, it has to be a perfect square, right? So 4 is a perfect square. Yeah. Yeah, because it has to break down to the square root of 4 is 2. It has to be that. Yeah. Or if you have the 12, just do the tree, right? And just count the answers, right? So this is what? 6, 2, and then 3, 2, and then just count that. So there's doubles of 2. So that'll cross out. Yeah. Yeah. You're welcome. Exact same thing. Matter of fact, I'm gonna do that for this next example. Now you don't have this on your homework, so but just humor me for a second, real quick, right? This is the cube root of 9 times 5 cube root. Oh shoot, 5 minus the cube root of 18. Now that's like what? 9 times 9 times 2. That's not gonna help me. So look, watch what I'm gonna do here. Just distribute. Just distribute, right? Cube root of 9 times 5 becomes what? 5 cube root of 9, right? So just distribute, right? Remember, numbers with numbers, radicals are radicals, right? There's a 1 here. So 1 times 5 is 5, 5 cube root of 9. And then we're going to distribute again. This is going to be negative, right? Now you just multiply the insides, right? So 9 times 18, that's I'm not even gonna hold y'all. Look, 18, 18 is 9 times 2, right? So this is just 9 times 9 times 2. Oh boy. Breaking that down. You know that 9 is 3 and 3. 9 is 3 and 3. And you have the 2. So these are the prime factors right here. So this is going to become 5 cube roots of 9 minus cube root of 3 to the third times the cube root of 6. Yeah, that's good. These will cancel. So I have 5 cube root of 9 minus 3 cube root of 6. The radicands are different. So this is my final answer. That's it. Just humor me. You're not going to get that in homework. You're not going to get that on a test. Third test. We're still on the third test, yeah. All right. Just give me one last example. One last example. I do have more to show y'all, like if you guys use your tricks or whatever, but as long as you know how to foil, you ain't got to worry about the tricks. Like the foil method works for everything. First, outer, inner, last. Yeah, yeah. Yeah. So this one example will suffice for everything else that We didn't get to today, right? So when we worked with polynomials, we multiplied binomials by binomials. Remember, this gave us four products. Before we combined any like terms, to be sure to get all four products, we organize our work usually by the FOIL method, right? First, outer, inner, last. All right. So check this out, check this out, check this out, real quick, real quick. So A, this is going to be square root 3 minus 2 square root 7 times 4 minus 2 square root 7. All right. Matter of fact, I'll just do this one and we'll call it, right? First, 3 times 4, that's 12, right? Then outer, excuse me. This is going to be 3 times negative 2 square root 7. This is going to give me a negative 6 square root 7. Inner, right? No, FOI, yeah, inner, right? So this is going to give me a negative 8 square root 7 last, right? This is going to give me a negative times negative is positive 4, right? Square root 7 squared, all right? Let's simplify this. The square root and the square will cancel out. So I have 12 minus 6 square root 7 minus 8 square root 7 plus 4 times 7 because they canceled out. 4 times 7, what's that? 7 times 14, 28. So I have 12 minus 6 square root 7 minus 8 square root 7 plus 28. Combine like terms, a fancy way of saying add. Numbers with numbers, radicals with radicals. 12 plus 28, what's that? That's 30, that's 40. Now, negative 6 square root 7 minus 8 square root 7 is going to give me a negative, right? What is that? 14 square root square root 7. And that's my final answer. When you see a binomial times a binomial times a trinomial, whatever, distribute, combine like terms. That's it. All right. It's the same thing with the x's. All right. I have some more examples to go over, but this is the gist of it. Right. If you could just do this one little trick, you could finish your whole homework. All right. Questions on this? Anybody? All right, let's call it at that. Can I take this down? All right. Just come sign out when you guys are done. Appreciate y'all.